Okay, so we've learned how to use the factor theorem to identify possible roots for a polynomial. After we do that, you can see here they chose positive 1, put it through into the x cubed, that's 7x squared plus 4x minus 12, did the math and got a remainder of 0. So then they knew that x minus 1 was a factor of the polynomial. Okay? So after we go ahead and use synthetic division, we find out that our other factor is 1x squared plus 8x plus 12. And we go ahead, take it one step down farther. There's our original factor that we tried after identifying the 1. We factor then x squared plus 8x plus 12 into its two factors, x plus 6, x plus 2. And now we have the three factors of this polynomial being x minus 1, x times x plus 6 times x plus 2. If I want to find the zeros, or where I am on the x-axis, I will set these three factors equal to 0. Now I solve for the zeros, which tells me that my graph crosses the x-axis in these three spots, where x is 1, x is negative 6, and x is negative 2. So then I can go ahead and plot those spots. Looking at it, I see that I came up with those three numbers from my factors, and now I can go ahead and just take x, where x is 1, negative 6, and negative 2, and put them right on my graph. X is negative 6, negative 2, and 1. And that came from my three factors and setting them equal to 0. Okay, so what do I want to do next? I still need to try to figure out some other spots for my graph. Okay, so the three zeros divide the number line into 4 intervals. So there we have 1, 2, 3, and 4 sections. Okay, so I'm going to choose some x's, at least that are in each of those sections, to try to get an idea of other spots. So I chose negative 7, one of those interval, a negative 4 was in this section, 0, and then 2. Then I plugged independent numbers in, because x is always our independent variable, into the polynomial, did the math. So when x is negative 7, y is negative 40, negative 4, y is 20, and so on. And then plotted those points. After that, then we get a pretty good idea, a picture of what this polynomial is going to look like. It has a line that continues off in that direction, this direction. So I know that the domain is going to be x, where x equals all real numbers. And in this case, the range is going to be y, where y is going to equal all real numbers as well, because it's going to continue that direction and that direction. So now that you can find the factors of these polynomials, you can then also graph them. That's how we use the remainder theorem, to the factor theorem, to synthetic division, finding the zeros in order to graph a polynomial.